I forgot to record that, so I'll make sure. Can you see that? So x plus y equals 176. 0x because there's 0% salt in that x, not water, 40% salt. And then that 8.8 came from timesing 176 and 0.05. You see that? And then hopefully on this recording I could show that top one, how I got that slope change. And okay, yep, I'll send this link to you for sure. Alright, that's 1 and 2. Number 3. They sold 45 for a total of $406.50. Women's shirts were $9.25. Men's were $8.50. How many of each were sold on Thursday? So it wants you to write a system of equations and then wants you to solve them. So we'll say W and M, I guess, for men's and women's. So my first equation would be M shirts plus number of women's t-shirts equals the total number that they sold on Thursday, which was 45. Do you see that? That's your first equation. The second one deals with the prices. So women's shirts were on sale for $9.25. Men's shirts were on sale for $8.25. Well, yeah, this one I'm looking at it. It doesn't. You don't know the price of shirts. Okay, well that makes sense. They're selling for $9.25. That's what they're saying. So my second equation would be the prices. So it looks like $8.50. So 8.5 M plus 9.25 W equals the total cost $406.50. That's that second equation right there. And so what I'm going to do, I'm going to solve this by elimination. I'm going to take that top row and times it by negative 8.5. So if I take that top row times everything by negative 8.5, that will set it up so that M variable will eliminate. And hopefully you can see that. Let me know. Yep. So when I rewrite that, that gives me negative 8.5 M on top and negative 8.5 W. And then if I times negative 8.5 times 45, that gives me negative 382.5. I use my calculator for that. Look at that. Oh, I can throw that too. Negative 8.5 times 45, negative 382.5. The bottom equation, I'm just going to rewrite it because it didn't change. And be good at these because you're going to have these for sure. Both the system problems and these ones. Give you a chance to write that down, and then anything in there confusing you that I did, for sure. You got that? So now what happens when you add and combine the equations straight down? The m's are going to cancel because they're opposites. And then that negative 8.5 and that positive 9.25, if I type that in my calculator exactly, so if I type in negative 8.5 plus 9.25, that gives me 0.75 right there. I got that from doing this part right here. So that gives me 0.75 W. And then if I take negative 382.5 plus 406.5, that gives me 24. And then the opposite of timesing by 0.75 is dividing by 0.75. And then 24 divided by 0.75 gives me 32. Yep. And then would you know how to do the men's shirts? Take 45 and there you go. Yep. Because the men's shirts would have to be what's left to add up to that to get you 42 or 45. So what do you get? 13 men's shirts. There you go. Not too bad, right? If it looks confusing the way it's set up, but truthfully on all of these word problem systems, that elimination method I did is the way to go. It's really the easiest, because otherwise you're doing substitution or you're having to use Desmos and plug it into a graphing calculator, which is kind of a pain. Alright, last one, number 4. So the system, let's see, I would write what I'm circling right here just as the answer for A, because that's just the system that we used. And then all that work we did below that, all the rest of that work, that's the B answer. All right, number 4. Okay, water output rate for Escobar is 30 gallons per hour. For Johnson's is 50 gallons per hour. Families use sprinklers for a combined total of 32 total gallons of 1320. All right, so I'm going to say E and J for the Escobar and Johnson family. Do you hear that? So for number 4, I'm going to say E for Escobar plus J for the Johnson family. Their total of water gallons is 1320. That's my first equation. My second equation deals with the rate of change. So for the Escobar family, it's going to be 30 E, because theirs is 30 gallons per hour, and the Johnson's is 50 J, and that equals 32 yes, 32 out equals 32. Let me look at that, because say 30 gallons per hour, they used it for 32 hours. Um, let's see. I think that might work. 30 gallons per hour, 50 gallons per hour. They combine for 32 total hours. Oh, you know what? I set up the equation wrong. It should be E plus J equals 32. So the number of hours. And the second equation is 30E plus 50J equals 1320. That's the number of gallons. So if I take that top equation, I'm going to multiply everything by what? Remember, like kind of like that last one? If I want to eliminate my E's. Not just 30 though, because that wouldn't, not 0.30 though. You want to have it the opposite of 30, negative 30. And that's going to distribute all the way through. That will give me negative 30E minus 30J, and then negative 30 times 32. 50J. That's okay. So negative 30 times 32 is negative 960. And then the bottom part stays the same. And then do you see what's going to happen right there? And then how many J's am I going to get? Got 20 J's. Good job. And then 1320 negative 960 360. And then right there, the opposite of timesing by 20, dividing. And that'll represent J, which is the number of hours for the Johnson family. What'd you get? $18. So that's for the Johnson family, 18 hours, and then if you take that away from 32, you'll get the number of the Escobar hours, 14. There you go. Write that down. I got that on video. Send it to you to double check. The system of equations. Yeah, well, both those, again, the first equation. What's that? I'm sorry. Yeah, but that wouldn't have made sense though, because the second part deals with 30 gallons per hour and 50 gallons per hour. It wouldn't make sense to set those equal to 32 hours. So that's why I set those equal to the gallon number. And again, these system problems, there's always the first system dealing with the amount of stuff, and then the second one deals with either the rate of change or the price. I don't know. But the first equation always deals with the amount of shirts or the amount of hours that these families use the sprinklers. If that makes sense. But yeah, once you get those equations in, it's not too bad. Yeah. All right. I'll stop sharing that because we don't need that for now. All right. What's next? Yep. Okay, can you go up to that top part? I'm going to take a picture of that. Okay, got that. So simple interest. That's not too bad. Nice. Yeah, you're doing that in Excel. Yeah, it needs to teach you. Yeah. Okay. All right. So, can you go to that middle part there? I didn't get a picture of that. That A part right there. Okay, so 1 year we just times by that, but then 2 years. I'm confused. So, okay, so I see what they did. So they took that amount after a year and they times that by 17%. Okay, so they're starting to set you up for harder interest problems, I believe. Because if you took 6,000 times 0.17 times 2 and you added that to 6,000, alright, I see what they did. Okay, so not too bad. Pretty basic. So you're thinking 8,500 times 0.12 right there? I get, yep. And then if you take that and add it to that original 8,500, that's how much you have in the account. There you go. And then if you take that 9,520 and times that by 0.12 again, I get, looks like $1,142.40. So if you take that and add it to 9,520, it will give you how much after 2 years. So it looks like, there you go. Yep. Yeah. Yeah. You should know how to do it on Excel though too. Hopefully the teacher teaches you. That's the interest, right? So make sure you don't type that in unless it was asking for the interest, but this wants the amount, so that's what I got. Ooh, not 0.7, right? There you go. Careful. It's gotta be careful now. That's what I got. There you go. Those are pretty easy. All right, so exponential growth, you're taking the amount times the percent. That's okay. All right. So they're just saying, whoops. You just go down. I think it's just this is the so you see they times the amount 3,900 times the percentage rate, and then that fifth power represents the amount of years that it was in the account. So do you know how to type it in your calculator? Yeah, because my calculator, I could type in that exactly. I could type in 3,900 times 0.915 raised to the fifth to get that 2,500. All right, these are pretty easy. All right, so it looks like 115 grams. How much after 4? half-life. Sorry, that's still confusing. So after one half-life, you're down to a half. So you're starting out with 1. After one half-life, you're down to a half. After another half-life, you're down to... No, that would be 1/4. Because you're having that again. And then one more half of that would be 1/8. I'm not sure if you're following along there. So if you take the whole quantity 1 and you half it, that gives you a half, right? And then if you take half of a half, you get 1/4. And if you take half of 1/4, you get 1/8. So that would be after 1, 2, 1/2, 2/2, 3. So I'd have to do that one more time to get 1/16. So I think that's the fraction I'm dealing with. 1 half-life, 2 half, 3 half-lives, 4. So if I take 1/16 and change that to a decimal, 1 divided by 16, that's 0.0625, which is 6.25%. And did you want me to show you that on paper? Or are you seeing? Okay. So you're going to take 115 times that 0.01625 raised to the 4th. Wait. Oh, wait, let's see. I think all you got to do is take 115 and times it by 1/16 or divide it by 16. So I was making this more complicated. So 115 divided by 16, I think you get 7.1 round to the nearest gram. So that would be 7 grams. If that makes sense? I think that's right. No, just round to the nearest whole gram. Okay, now these are the real ones there. So you take that 26,000 times 0.087 raised to the 8th power. So you have to use your calculator for that one. So I could type mine in exactly 26,000 times that as a percent is 0.0875. And I'm going to raise that to the 8th power. And hopefully you got your calculator can do that too. Ooh, I get a small number, something's not right. What'd you get? Huh. I did something's wrong here in this one. What am I doing? So maybe you don't change that to a decimal. Maybe you leave that point 875. God. No, that's not right. I got a small number. You know what? Let's just check the explanation. Let's see what it says. Just bite the bullet. Missed that first one there, so that was easy. Ooh, compound interest. That's right. Let me take a picture of that. All right, go down. I think they just used the formula at the bottom there. Right there. Oh, I see what I did. I used the wrong percent. Instead of, you got to use 1.0875 for that percent because it's the whole plus that little percent added to it. Oh, I see. Yeah, I was using, instead of 1.0875, I was using 0.0875. All right, that makes sense. All right, we got them. Easy peasy. Okay, 1250 each year decreases by 25%. What is the resale after 3 years? So take 1250 times decreasing by 0.25. So if you have 1, which is 100%, going down by 0.25, that would be 0.75 is my percent to the third power. Let's try that. Let's take a picture of that. And that gives me 1250 times 0.75 to the third. So I get 527. So yeah, I get 527 nearest dollar, so $527, I think. I'm pretty sure on that one. Yeah. Alright, so you got 8.75%. That means the total that's going up is 1.0875. So this formula is 2100 times 1.0875 raised to the 11th power. I'm going to send you a picture of that. Should be coming. And then hopefully you have a good calculator, because I typed that in exactly the way that looked, and it gave me 5,283.7, so 5,284 when that's rounded up. And you're able to get that 5,000 Yeah, because sometimes on the phone it's a little dicey in terms of the numbers that you plug in and the order of operations. So, yeah, it's dicey on the phone, but it looks like you got it. Okay. Wow. Okay. All right. Compound interest. Look at that formula. Compound interest A is P principal percent total. There we go. The final amount A. All right. That's what that means. Makes sense. Have you ever used that formula before? I mean, you're just plugging that in. P is the principal, how much you're depositing. R is the percentage rate as a decimal. N is the number of times it's compounded each year. And then T is the total amount of years when you plug it in. So we'll go down a little bit. All right, so that's pretty straightforward using that formula. And then, can you go up one more time? I want to take a picture of that formula here, so we got that. All right. Easy peasy. Yep. Got him. So 2,000 is your principal. The percentage rate. Yep, so that as a decimal moved twice to the left is 0.028. And then the number of times it says compounded annually, so that means once a year. That's 1. And then NT would be that one time times 8. So now it's just up to you to type all that in. Let's see if I can take a picture of that. So these on my calculator are way lot easier than using your phone, that's for sure. So on your phone, you'd have to almost do the 0.028 divided by 1 first, and then add that to 1, and then raise that answer to the 8th power, and then times that by 2,000. That's a trick. But on my calculator, I'm going to type it in exactly as I see it. Are you trying it on yours? Eighth. Do you have it close by to you? Is it buried in a box or something? Okay, so if you're using your calculator, do you want me to walk you through the process? Mm-hmm. Because I'm trying it on my calculator, and it's a little more difficult. Because it doesn't write it out. Each time you do a calculation, it gives you a number. So if you're using your calculator, you're going to have to do, I'm telling you, take that percent, that 0.028, and divide it by 1 first. And that should give you 56. And then you have to add that to 1. So if I take 0.028 divided by 1, that gives me 56. I'm sorry, let's do that again. Wait, you're right. So 0.028 divided by 1 is 0.028 plus 1. It's 1.028. And then you raise that to the 8th power. So that gives me 1.2472. If I times that by 2,000, I get 2494.45. I got that 2,494.45, which rounds to 2,494. Oh, near cent, so $2,494.50, or shoot, no, that would be. I'm sorry, let me do that again. Is that your cat? Yeah. I get 45 cents. So yeah, 45. I think that's good. Yeah. So compounded quarterly, that means that n number is 4. Yep. So we got 8,000 times 1 plus that percentage rate, 0.195. Ooh, there you go. Look at that. Use this. Yeah, use that. So type in. So 8,000, type that in. Parenthesis 1 plus and then that would be 0.195, and on the bottom you got 4, so it would be 4, right? Yep. And then that would be raised to the 4 times how many years in this one did it say? So 4 times 3, so the 12th power. Hopefully you're seeing where I got that 12. You want to use that x to the y, but oh, there you go. You got it. That's it. Dollars and 90. See what that would round to. There you go. Yeah, that that calculator is the way to go because you can type it in and see exactly what you're seeing. So from here on out. Okay, look at this formula. Let's write this down. What was the question? Can you go up? Oh, that is the question? Find the initial after 8 years. So T is 8. Wait. Okay. You could go down. So 0, 8. Okay. You go down there. Alright, that's pretty easy using that formula. You should have E on your calculator there. Yeah. So your first one is going to be when you plug in H is 0, which is just going to give you negative 0.25 times 0, which is 0, which gives you e to the 0 power, which is 1. So you're going to have to do 15 times e, that e to the x button. Do you see that? And then that would be to the 1 power right there. I'm sorry. To the 0 power there. There you go. Yep, because if you plug in h is 0 for the initial amount, that gives you 0 e to the 0 power, which is 1, which gives you 15. So that should be good. That's the initial amount. You're going to do 15. Yep. So 15, hit that, times e to the x. And then there put negative 0.25 times, and then up there that's got to be up there, the exponent though. It's going to be times 7, if you could do that. There you go. 7. All you gotta do is there you go. So rounded to the nearest hundredth. So 10th, yep, 2.61, that's right. So you're going to type in 12 for x, and then you're going to do another one for 20 for x. No, you want to type in that that -8 plus 30 and then E, there you go, yep, and then -0.04 times 12 up there. Good job. That's it. So nearest whole degree, that would be 11, right, for that one? Yep. 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 Just 0.05. Jamming. Those are easy. It's nice. Sure, a little bit. We do another section or two, whatever. All right. Ooh, asymptotes. Here we go. So plot the x values and draw the asymptotes. Wow. All right. Let's look at that explanation. Wow, that's complicated. Just go down. I think they're just trying to tell you some stuff. All right, now for the real problem here, you're plugging in -2, plugging in -1, you're plugging in 0, you're plugging in 1, you're plugging in 2. Okay, I mean, you're just plugging in those values, kind of like a table. Next, draw the horizontal asymptote. Okay, you go down. And then let's go up to the original problem there. Right there, perfect. And this has a y asymptote of 0. Going back to those asymptote problems, let's see for, okay, let's go back. Sorry. So I think this is that one where you got to look at the degree and you got to see. This one has n less than m, so the degree. God, I don't know why it has an asymptote of 0. All right, I think we could get these problems done, Sabri. If you want to try one. Okay, what's the problem? So I would use your calculator. Oh, it's not letting you use a calculator. So you got to do 4/5 to the -2 power. And then using your phone, I guess you'd have to use your phone. Man. because my calculator could do that easy, but yours, you're gonna have to do 4, like in parentheses, 4/5, or 4 divided by 5 raised to the -2 power. I get 0.64. If I use my other calculator, 4/5 to the -2 power. Ooh, my other calculator gave me 1.56. Is that what you got? You got 1.2. Yeah, because 4/5 raised to the -2 power, my calculator gives me 1.5625. So I guess that would be your first point right there. So go to that little point box. Oh, you could do a fraction in here? Okay, so type in, what was that, -2, right, for x? -2. And then the y, let's try to use that button on the bottom right there. That's 4/5. That one right there, I guess. But it doesn't let you raise that to the -2 power, huh? What's that bottom right one? That's a mixed fraction? Alright, so if I did 4/5 to the -2 power, that's the same as 1/4/5 to the second power, which is 1/1625. So that's 25/16 right there. That first fraction, 25/16. There you go. And then if you plug in -1, you're going to get 5/4. Yep. And if you plug in 0, you're going to get 1. Because anything in the 0 power is 1. If you plug in 1, you're going to get 4/5. So 1 is 4/5. And if you plug in 2, you're going to get 16/25, I think. And then the asymptote is going to be, you want to do a dotted line through x equals, or y equals 0. So not that one. Just click that, close that. Go to that vertical or that horizontal dotted line right under the eraser, perfect. And that's going to go right through 0, x equals 0, right there, perfect. I think that's it. And then graph that, yeah, see that. There you go. Worked. So what I'm doing is I'm plugging in -2 into that, and I'm changing it into a fraction. Do you want me to show you that math? Can I show you? Can I share it with you? Can I show you? Alright, you're going to have to unshare that for a second. Alright, so I'm taking that fraction, which was, what was that fraction again for that problem? So 5 over 3. And the first thing I'm going to do is I'm going to raise that to the negative 2 power. Can you see that right there? So the tricky math on that one, I'm putting that over 1. And then the math lets me flip-flop that and write that power as a positive power right there. So 5/3 of the negative 2 over 1 is the same as 1 over 5/3 squared. So if I do that math, that gives me 1 over 25 over 9. Hopefully you can see that. And then if you take the bottom and you times 1 by that reciprocal, that gives me 9 over 25. So that's how I got that weird fraction, by plugging in negative 2 in there. So I'll let you go back to yours there. I'll stop sharing. Hopefully you saw that. So yeah, that first fraction is going to be negative 2 9/25. And you got that on video there, so hopefully if you want to go back and look at that. That's kind of weird how I got that though. If I plug in negative 1, that's just going to give me 1 over 5/3. So if I times that, that gives me 3/5. That's going to be negative 1 3/5. There you go. If I plug in 0, that's going to give me 1. Anything to 0 power is 1. And if I plug in 1, that's just going to give me 5/3. And if I plug in 2, you're going to get 5/3 squared, which is 25/9. And then looks like the asymptote again is that 0, the x-axis. There you go. Plot that. That should be good. One more. It's lunchtime. Okay, would you know how to do 3 to the negative 2? Yep. How would you do that? Because I get 3 to the negative 2 over 1. I'm going to flip-flop that, so that's 1 over 3 to the positive 2. What'd you get? Take a look at that picture I just texted you right there. Nope. So it looks like it just came through. So 3 to the negative 2 power written as a fraction. Yep, because 1 over 3, the positive 2 is 1 over 3 squared, which is 1 over 9. So that first fraction, negative 2, and then 1/9. And if I plug in negative 1, that just gives me 1 over 3 to the first, which is 1/3. So negative 1 would be 1/3 on that one. Always 1, there you go. So, nope. If you plug in 1 into 3 3 to the x power, that would just give you a plain old 3, right? There you go. And then if you plug in 2, 3 squared, it gives you nope, 3 squared, 3 times 3, because you're plugging in, there you go, positive 9. Nope, not because you're not plugging it into negative, it's not a negative. There you go. And then looks like you got to do that asymptote again. Yep, right there. That should be it. Yay. Alright, I will send you this link right away so I don't forget. Nah, stop it right here. I'm going to text this to you.